It was the middle of the night shift. Our maintenance shop received a call from the packaging line. The voice on the radio sounded desperate. It was my turn to answer the call. I picked up my tools and walked toward the line. What I saw when I arrived was utter chaos. I want to tell you what happened next, but more than that, I want to tell you what this story reveals about what happens when preventive maintenance schedules are no longer treated as non-negotiable. Hamburger buns were coming off the Racetrack cooler and being blown off the packaging line by the pressurized air nozzle positioned after the metal detector. The detector warning light was flashing on and off like the lights on a police car. Every time the light turned red, the nozzle fired. This is not a quiet blast. Everyone in a bakery knows what that sound means. The buns were supposed to fall into a catch chute that led to a locked access door. Only quality control could open it, but the chute had filled up. Buns had nowhere to go, so they were flying into the air instead. Production personnel were scrambling to catch them with packaging baskets before they hit the floor. The production supervisor was in the middle of it, sweating, red-faced, yelling instructions. He saw me and walked over. He told me the detector had gone wild without warning and I needed to fix it. I nodded. Then I told him to stop loading the Racetrack cooler with product from the oven and to stop the cooler itself. He looked at me and said he was in the middle of production and could not stop. Fix the detector, he said. While we were talking, his manager walked onto the packaging area behind him. The manager immediately signaled the oven operator to stop the depanning unit. He called for pan carts and insulated gloves. He ordered personnel to load the carts with the hot product still coming out of the oven. He called the dough makeup line and stopped it as well. The line was automated. Everything already in the steam proofer had to be removed by hand. Then he turned to me and asked what I thought. I told him the same thing I would tell anyone in that moment. Before I assume the detector is the problem, I need to inspect the product. Detectors do not fail randomly. I took a basket of buns from the floor near the failing detector and walked to the dinner roll packaging line. All detectors in this plant were the same brand and model. That was a standing policy for consistency. The dinner roll line was idling between batches. I placed a handful of the hamburger buns onto its detector conveyor. The light turned red. The nozzle fired. Buns rejected. I placed another handful on the same detector. Same result. Then I took the basket to the portable quality control detector, set it up for the hamburger bun product parameters, tested it with the standard metal test sticks to confirm it was calibrated, and ran the buns through. Same result. Red light, rejection. The manager and the quality control personnel who had gathered to watch were speechless. 3 detectors. Same product, same rejection. The detectors were not failing. They were doing exactly what they were designed to do. While I was finishing the third test, a production worker called the supervisor over. Something odd under the Racetrack cooler. Then I was called over too. The supervisor pointed to a spot on the floor. I looked down. Dim, shiny dust scattered across the concrete. I shone my pocket flashlight on them. Metal. I looked at the cooler and moved the flashlight beam along the tiers. At the level where the main drive sprocket engaged with the chain, more metal dust. My heart sank because I knew exactly what this meant. The cooler used spring-loaded pressure shoes to maintain constant sprocket and chain engagement. Those shoes had strips of hard plastic attached to their contact surfaces, engineered to prevent metal-to-metal contact while still allowing proper chain tension. When those plastic strips wear down, the shoes go metal-to-metal against the moving chain. That contact generates metal dust. The dust falls onto the product below. The metal detector catches it exactly as it was designed to, and the bakery has a full production line of contaminated product with the correct rejection response happening in real time. The pressure shoes on that cooler were on the weekly PM inspection schedule. The task was simple. Visually inspect the condition of the plastic wear strips, measure wear against the replacement threshold, and replace them when the threshold was reached. It was not a difficult inspection. It was not a time-consuming inspection, and it was not being done. For the previous 2 months, maintenance resources had been redirected away from routine PM inspections toward other work priorities. I had raised concerns about this pattern more than once. Downtime reports were already trending up. Signs of neglect were becoming visible on multiple systems, and now this. A full production line down, 24 hours of overtime repair ahead, a customer supply commitment at risk, and a completely preventable equipment failure that a 5-minute weekly inspection would have caught long before it reached the point of chain contact. The damage to the cooler was extensive. The entire belt was ruined by metal-to-metal contact. Fortunately, a replacement belt had been ordered previously and was sitting in the warehouse. 12 wooden crates of 10-foot belt sections, along with new wear strips and new pressure shoes. Before this situation, someone had recognized that this equipment needed spare parts on standby. That decision made the difference between a 24-hour repair and a multi-day shutdown. I worked significant overtime during that repair, but the cooler was rebuilt and running. After the incident, the maintenance program returned to its scheduled inspection intervals. The weekly pressure shoe checks were added back to the calendar, and they were performed. Every video on this channel is a real story from 40 years in commercial bakery maintenance. This one is about the difference between a preventive maintenance program that exists on paper and one that is actually performed. When PM inspections are redirected, for any reason, equipment fails on the exact schedule the program was designed to prevent. The detectors in this story worked perfectly. The problem was upstream of them. It was in the maintenance decision to skip a weekly inspection that took 5 minutes and prevented a 24-hour shutdown. Subscribe for new content every week. Free field reference covering 25 equipment failure points. Link in the description.